Hello, Mathletes. Good day. Welcome again for a new episode of Math Amazing Lecture. And for this moment, we will be learning about the chain rule. And for this session's objective, at the end of this lecture, everyone is expected to illustrate the chain rule of differentiation and solve problems using the chain rule. The derivative of polynomial function raised to the second power such as y is equal to 4x minus 3 raised to the second power can be found by either multiplying the polynomial by itself and then finding the derivative of the product, or by using the product rule of derivatives. If your 4x minus 3 is raised to a higher power such as 8, to expand, it is very time consuming unless the binomial theorem is used. Problems arise if the polynomial raised to a higher power contains more than two terms. Now, the derivative of a radical function such as y is equal to the square root of 3 minus 5x can be found by using delta method for derivatives. But this too is very time consuming. The chain rule is needed to find the derivative of some functions such as of those mentioned. It is also needed in computing the derivative of trigonometric and exponential function. Now, let's have the definition of chain rule. According to the chain rule, if u is equal to g of x and y is equal to f of g of x, then the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Now this rule can be proven using the Leibniz notation, but we will not discuss that this moment. Rather, we will be using this chain rule to answer different problems. Now let's have example. For example number 1, we have y is equal to 5, or the quantity of 5x plus 4 to the second power. In our previous topic, this function can be solved, or the derivative of this function can be solved using the product rule. But this moment, we will use the chain rule in order to get the derivative of this function. Now let's do it. According to the function, the derivative of y, which is y prime, we need to get the derivative of the outer function. Then let's proceed to the inner function, because there are two functions here. That's why we call this one as composite function. So let's apply the power rule. Let's put these two here, then copy the whole 5x plus 4, and don't forget to subtract 1 from the exponent. So 2 minus 1 is 1, so there's no need for you to write that 1. And let's always multiply the derivative of the inner function, which is 5x plus 4. And what is its derivative? Yes, the derivative is 5. Now, simplify it further. We have 5 times 2 is 10, times 5 is 50, times that x, so we have 50x. 5 times 2 is 10, plus, or times 4 is 40. So there you have it. We have the derivative of y is equal to 5x plus 4 to the second power is equal to 50x plus 40. Now let's proceed to the second example. The second example is y is equal to the quantity of 7x minus 4 raised to the third power. So the same manner, we need to get the derivative of the outer function. Let's put that 3 down. Then copy 7x minus 4. Don't forget to subtract 1 from the exponent. So 3 minus 1 is 2. Then always multiply the derivative of the inner function, which is 7x minus 4. And what is the derivative of 7x minus 4? Yeah, you're right. It's 7. Then let's simplify. We have y prime. 7 times 3 is 21. Then let's copy 7x minus 4, the quantity raised to the second power. So yes, this is now the derivative of the given function y is equal to the quantity of 7x minus 4 raised to the third power. There is no need for you to distribute 21 or multiply 21 to 7 minus 4 because we have exponent 2. Now, let's have the third example. The third example is 3, or the quantity, or I'm sorry, that's number 3. Y is equal to the quantity of 3x squared minus 7x plus 9 raised to the second power. So let's apply the chain rule. That's y prime is equal to, bring your 2 down here, copy your 3x squared minus 7x plus 9. Don't forget to subtract 1 from the exponent 2. So there, 2 minus 1 is 1. And there's no need for us to write the 1. Then let's multiply the derivative of 3x squared minus 7x plus 9. Its derivative is 6x minus 7. Okay, let's expand or simplify. So let's write 2. Then let's have, or let's expand, let's multiply these two polynomials. We have 6x times 3x squared is 18x cubed. 6x times negative 7, so that is negative 42x squared. Positive 6x times 9, that's 54x. Then let's have this second term, negative 7 times 3x squared is negative 21x squared. Negative 7 times negative 7x is positive 49x. Negative 7 times positive 9 is negative 63. Okay, so that's it. Let's simplify further this one by combining like terms. So we have 18x cubed combine negative 42 and negative 21. So that would be negative 63x squared. We have 54x and we have 49x, and that is equal to positive 9, 3, carry 1, that's 103x, and we have 63 there. No partner, so just copy negative 63. Okay, so for the final answer, we need to distribute 2. So this is 36 x cubed minus 126 x squared plus 206x minus 126. So this is the derivative of that given function y. Alright, let's proceed to the fourth example. The fourth example is y is equal to the square root of, we have the 3x minus 8. So let's find the derivative of this radical function. Now, there are methods in other references that we can directly solve the derivative of this, but for the sake of the use or the application of chain rule, we could do that by rewriting the given radical function into its exponential form. So let's transform, convert, or rewrite this radical into its exponential form. So you need to review your laws of exponent for you to rewrite that one into its exponential form. So we have this form a raised to m over n. In radical form, that is equal to the nth root of your a raised to the m power. The denominator of the fraction becomes the index of the radical function, and the numerator is the exponent of the base a. So here, we know that if we use the square root symbol and there's nothing or there's no number written in the index, in the index, it is understood that the index here is equal to 2. So we could rewrite that one into 3x minus 8, put parenthesis sign, that the index is 2, that's why the denominator is 2, and we know that this whole base is raised into 1, so that's the numerator. So we have an exponent 1 half. Now we are now ready to apply the chain rule. The chain rule says we need to bring your 1 half down here and copy your 3x minus 8. And don't forget again to subtract 1 from the exponent 1 half. And 1 half minus 1 is negative 1 half. Then let's multiply the derivative of your inner function, which is 3x minus 8, which is equal to 3. Then let's simplify it further. So y prime is equal to 3 times 1 half is 3 halves. Then let's copy your 3x minus 8 raised to negative 1 half. Um, this is considered to be the final answer, but in my class, I would, or let's have an agreement for us to write the correct answer or the final answer. Since the given function is in the form of radical, so it is but proper for us to transform your final answer into a radical form. Now, how to do that? So again, we will use this laws of, or this law of exponent, the rational exponent. I think that's the name of that laws of exponent. So let's do it. So here we have 3 halves, and since the exponent is negative, to make that positive, let's put that in the denominator. So we have 3x minus 8 raised to positive 1 half. Yes, according to one of the laws here, well, let's say we have a raised to negative x. Okay, for you to make the exponent positive, we will put our a raised to negative x below for you to make that negative exponent be positive. Now let's go back here. We have y prime is equal to, since our main objective here is to put this one into its radical form. Then let's do it. We have 3 all over 2. Since the exponent is 1 half, so the index is 2, and there's no need for me to put that 2 here. So I'll just copy my 3x minus 8, the quantity 1 power, but there's no need for you to do that because it's automatic that this one is being raised into 1. So this now will be our final answer in getting the derivative of this given function. Y is equal to the square root of 3x minus 8, which is equal to 3 all over 2 times the square root of 3x minus 8. Okay, let's proceed to the fifth example. Okay, for the fifth example, number 5, y is equal to 3x minus 2 times the quantity of 5x plus 3 raised to the third power. Here, we will be applying several rules or laws of differentiation. So we will be applying the product and the sum and difference rule, the product rule, and even the chain rule. So let's do it. So if you observe, there are two multipliers, the multiplicand and the multiplier. So there are two factors. We have 3x minus 2 and the quantity of 5x plus 3 raised to the third power. So let this be our u function and let this be our v function. So if you remember, the derivative of u times v is u dv plus v du, right? So we will be applying this for us to get the derivative of this one. So let's apply the product rule. So y prime is equal to u, just copy your u, and that is 3x minus 2 times the derivative of the v, derivative of v. Now, for you to get the derivative of the v function, we need to use the chain rule. Yes? So, we need to bring your 3 down, the exponent, copy your 5x plus 3, and always don't forget to multiply the derivative of the inner function 5x plus 3, which is equal to 5. Now, going back to the product rule, that's plus, and let's follow this one. Copy your v function. The v function is 5x plus 3 raised to the third power, and the derivative of u is 3x minus 2. Its derivative is equal to 3. Now let's simplify this further. Y prime is equal to 5 times 3 is, yes, that's 15. Let's copy your 3x minus 2 times your 5x plus 3. Oops, I think we've missed something here. We need to subtract 1 from the exponent 3. That's why we need to put the exponent 2. Okay. Buti nakita natin. So that's 2 plus, just copy this one. That's 3 times 5x plus 3 to the third power. Okay? So for me, this is now, or this can be our final answer. But if you want to expand this one, it's also okay to me. But bakit pa? Ba't mo pa papahirapan yung sarili mo? So parehas lang naman yan. So this will be our final answer. The derivative of the quantity of 3x minus 2 times the quantity of 5x plus 3 to the third power, or raised to the third power, is equal to 15 times the quantity of 3x minus 2 times the quantity of 5x plus 3 raised to the second power plus 3 times to the quantity of 5x plus 3 raised to the third power. Okay, so let's proceed to the sixth example. From the sixth example, we have the given y is equal to 3 all over the square root of your 3x minus 3. Okay? So, for us to apply the chain rule again here, we need to transform or convert the given radical or rational radical form into its exponential form. So, let's rewrite. So, I did not put prime here because I'm not yet solving the derivative. I am just rewriting it. Oh, dapat klaro tayo doon. Kung hindi nyo pa sinasolve yung derivative, huwag muna kayo mag-prime. Ngayon, kapag nag-prime na kayo agad dyan at nakita ko sa solution nyo, that will be a mistake or wrong. So, punta tayo dito. So, let's rewrite it. So, that will be 3 all over. It's 3x minus 3. Convert it into exponential. Raised to 1 half. Pero hindi pa tapos. Ilalagay natin yung denominator dito sa taas. So, there is a consequence in doing that. So, ano yung consequence? Yung 1 half na positive magiging negative. Bakit ko gagawin yon? For me to convert that into a more or into a simpler equation. So, from this, I am now ready to apply the chain rule. So, let's put prime in the y to indicate that we are now solving the derivative of that given function. So, here, let's copy your 3 and multiply to this exponent, which is negative 1 half. Copy your base, which is 3x minus 3. Oops, again, don't forget to subtract 1 from the exponent. So negative 1 half less 1 is equal to, what do you think? It's negative 3 halves. Yes, you're right. And again, don't forget to multiply the derivative of the inner function, which is equal to 3. Now let's simplify. Y prime is equal to 3 times 3. It's 9 times negative 1 is negative 9 over 2. Then let's rewrite this one as 3x minus 3, the quantity raised to negative 3 halves. Then since our agreement is since the original given function is in radical form, then let's rewrite this one into its radical form. So we have y prime is equal to negative 9 over 2. Yes. Then we have the square root of, put that into the parentheses, 3x minus 3, and let's raise it into the third power. So this is our final answer. The derivative of 3 all over the square root of 3x minus 3 is equal to negative 9 over 2 square root of the quantity of 3x minus 3 to the third power. So this is now the derivative. So again, that ends our math amazing lecture. I hope you've learned something. Happy learning!